Good morning, everyone. So today we are going to discuss about the OpenGL architecture. Okay, OpenGL architecture is structured as a state-based pipeline. So on the screen, we can able to see the OpenGL pipeline architecture. So first of all, that is the command which we are going to give for the OpenGL pipeline. And for this, the first one is the display list. After that, the display list transfers the commands to the evaluator, and then it is transferred to the per vertex operations and primitive assembly. Then it is going to be rasterized, then per fragment operations, frame buffer. And then after frame buffer, it is transferred to the pixel operation, then texture memory, and the output is also, if it is not in a proper way, then again it is going to rasterize. After this, the display list is also given to the pixel operations. Now we are going to understand about the each and every blocks, how they are going to play the important role. First of all, that is a display list. The importance of the display list, it is used to accumulate some command in a display list for processing at a later time in a batch mode. For example, GL new list that is going to use for the creation of the display list. GL end list, that means it ends all the list which we have given in the display list. GL call list for the execution of the list or the set of list which we have given. GL delete list function. This all are the functions for deleting a set of display list. Okay, so this is about the display list we are going to use. The next one, that is the polynomial evaluator. Polynomial evaluator is used for efficient means for approximating curve and surfaces geometry by evaluating polynomial command of the input values. Whenever the input values it is given, then it is going to calculate the approximating values for the curves and the surfaces by the geometry. Okay, next one is the per vertex operations and primitive assembly. This is going to be used for the point line segment or the polygon vertices. Okay, next one is the rasterization. We have studied about the rasterization in the first unit for the basic part. It produces a series of the frame buffer address and associated values using a two-dimensional description of a point of a line segment. This is called as the rasterization. Next one is the per fragment operations. Okay, that is per fragment operation is used for the Z buffering and the blending of the incoming pixel color with the stored color and masking other logical operation on the pixel values are done. So if we are going to use for the 2D object or the 3D object, for the 2D object we have to consider the 3D point or the Z axis as a 0, and while we are using the 3D object for converting from the 4D object to the 3D object, we are going to use X, Y and Z axis and the W or the fourth quadrant, that is if it is non-zero. Okay. Next one is R, that is the frame buffer. Frame buffer is used Frame buffer is used in a rectangular array of n bit planes. Bit planes are organized into the several logical buffer. For example, color, that is the information of the fragments. Depth, that is the depth information of the fragment used for the Z buffer, how depth the color is going to be filled. For example, painter's algorithm or some other Z buffer algorithm. So if we are going to draw any picture, we require the last color coordinate which is going to be filled in the first manner. Then upper colors are going to be filled if we are going to display any picture in a proper manner. Then stencils, that is a fragment that pass conditional test, and accumulation, this all are the part of the frame buffer. The accumulation, it can average the value stored in the color buffer. Okay, so this is the important role of the frame buffer. The next one is the pixel operation. Input data can be in the form of pixel and it is processed in a pixel operation stage. That means we have to implement the pixels in the on the screen. And the last one is the texture memory. Texture memory is the images or the geometry passed through the separate pipelines and joined through the rasterization. This is the role of the texture memory. That means if we are going to plot any images or the geometry, they have to separate through the different pipelines, because if we are talking about the images or any objects, that is the contains different part, because some of the images are of 2D or some of the images are of the 3D pattern. So they have to travel through the different pipelines. and then they are going to be joined at the rasterization. So you can see here we are having the arrow at the rasterization. So this is all about the OpenGL architecture, that is a state-based pipeline. So the description is also given here. You can go through with the description. The first stage here it is given, that is first of all the display list which we are going to give the command, then the pipeline evaluator, then the per vertex operations. The third stage is rasterization. Fourth stage is per fragment operations and the part of the frame buffer. Okay. So the vertices and the primitives we are having, so we are having different type of objects, that is the line, points or the other polygon shapes. So we require the number of vertices, number of the particular edges. So we have to draw the vertices, number of edges in a different color or the same color, depends on it. So points are there are the 10 primitive types such as points, individual points. That means we can able to see vertex 0, 1, 2, 3. These are the individual points. If we are going to talk about the lines, that is a pair of the two vertices. That is V0 to V1, V2 to V3. These are the line segments. If we are going to talk about the polygon, that means it is a boundary of the simple convex polygon. So we require number of vertices to form a closed loop to get an object, that is called as the polygon. If we require the triangle, that means we are having the triple of vertices interrupted as a triangles. If we require the quadruples, that means we require the four-sided polygons. Line strips, that means the continuous line segment in a series format. For example, V0 to V1, V1 to V3, V2 to V3, V3 to V4. So it is a continuous line segment which is drawn by connecting the two vertices. Line loop, that is we are connecting the number of lines and forming a closed loop. Okay. Triangle strip, that means we are having a particular link strips of the triangle in a particular polygon. Triangular fan, that we can able to see the shape of the particular in a form of the triangles and it is forming a fan like structure. Quad strips, that means it is in the quadrilateral form and link strips are there. Okay, these are the different primitives we can discuss about it. So I have already explained, if we are going to use about the 2D object, then we have to assume the z coordinate is of 0. If we are going to use 4D homogeneous coordinates and reduce to the 3D object, then we have to divide it x, y and z by the w coordinate if it is non-zero. Okay. So we can decide about the color values and the color index as well. So this is about the vertex and the attributes we are going to use. And I have already discussed about the commands are not associated with the primitive and it is not allowed with the begin or the end blocks. This allows increased optimization of the primitive processing. Okay. Lightning parameters such as the material properties, light source properties and the lightning model parameters affects lightning on a per vertex basis, because if a particular vertex of the particular edge is in a lighter mode, then we have to form that in the lighter mode and the other part is in the darker mode. So we have to give the reflection part. Clipping and the projection is also there. Once a primitive has been assembled, it is a subject to attributary clipping by user the definable clip planes. An OpenGL implementation must provide at least 6 and they may be turned on and off independently by the user. Points are either clipped in or out depending on whether they are fall inside or the outside the half space defined by the clip planes. Lines and polygons, however, may either be 100% clipped or 100% unclipped, because the line is completely outside the window or maybe completely inside the window. So it totally depends on the line segment. Okay, so that is the same mention here. After clipping, vertices are transformed by the projection matrix and then clipped to the view space, following the same process as above. Okay, so this is about the clipping and projection. We have already discussed about the clipping and projection, then also I have explained here. So the rasterization converts the above view map primitive into the fragments. Fragments consist of the pixel position in the frame buffer, color, texture coordinates, Z buffer, depending on the shade modes. Vertices attributes are either interpolated across the primitive of all fragments or all fragments are assigned to the same value based on the vertex attributes. How we are going to draw the line segment, it totally depends on the rasterization and the pixel values which we are going to use or which we are going to store in the frame buffer. Okay. Rasterization is affected by the point and the line width, the line stipple sequence and the polygon stipple pattern. Anti-aliasing may be enabled or disabled for each primitive type. If enabled, the alpha color, if an RGBA mode or color index are modified to reflect subpixel coverage. Pixel rectangles and bitmaps are also rasterized, but they bypass the lightning and geometrical transformation. They are the group of the values heading for the frame buffer. They can be scaled, offset, mapped via the lookup tables. The rasterization process produces a rectangle of fragments at the location controlled by the current raster position state variables. So this is about the rasterization. So these are the texturing and the fog. That means we have to mention or we have to draw any particular polygon or the object which we are having the texture, that is the opaque texture or the transparent texture or some other kind of texture we are having an object. So we can use here the texturing and fog as well. Okay. The texture being mapped may be the filter by the variety of texture filters, each a trade-off of quality versus computational cost. Map maps may be specified allowing smaller representation of the texture to be used when the projected size of the primitive is small. It can be applied to the fragment. This is a blend of the fragment color with the constant user specified fog color. The blend is based on the distance of the viewer from the fragment. How much distance is there between the user viewing part and the object is placed. So that it totally depends on that how much the particular object is going to be visible in a clear form or it is in a particular blur form. So we are going to form that color. So next one is the frame buffer, which I have already tried to explain you while the explanation. Per fragment operation also explained you here. The per fragment operation is used here for the particular for while we are placing into a frame buffer. Each fragment may be subjected to the series of the test and modification, each of which may be individually enabled, disabled or controlled. This is include tensile test, depth test and blending. So I have tried to explain in the shorter manner while we are explaining about the diagram. So basically in the per fragment operation we are going to perform the operation like Z buffering, blending of the incoming color pixels with the stored color and masking other logical operation on the pixel values that are given to us. Okay. So which particular pixel value is valuable? So we are going to plot that. So this is about the per fragment operation. So we have discussed about the evaluator, display list, feedback selection, and if still you are facing any doubt, you can ask. Thank you for this particular thing.